Let us start, Tina sir.
Shall we start, sir?
Yeah, please.
Respected Sri UK Srivastava, sir, DG NTI, senior officers, colleagues from DOT headquarters, LSAs, BSNL, MTNL, and other units, learned speakers in the session, participants from various fields, academia, fellow colleagues from NTI, ladies and gentlemen. Very good morning to all of you. On behalf of NTI, I, Raju Sinha, DDG Transmission and NGS, welcome you all. We assembled this forenoon in the webinar on trends in cellular backhaul system. Dear all telecom professionals and aspirants, we will appreciate that evolution in cellular system focused on increase in data speed to the cellular users, static or mobile, in the given network. Increase in speed and other features in access part pushed the backhaul network to change stance, gear, and design to cope up with the increased traffic, throughput, routes, etc. The backhaul could be optical or wireless, that we will discuss here. Dear participants, there will be sea change as cellular network evolves from 4G to 5G. In 5G networks, the ultra-dense and heavy traffic cells will need to support hundreds of gigabits of traffic from the core network to backhaul. Today's cellular architecture needs to be feasible to meet this extreme requirement in terms of capacity, availability, latency, energy, cost efficiency, and much more. This network could be low band, mid band, or high band deployment, where high band promises more than 1 Gbps speed. Though 5G made inroads in few parts of the globe, we are yet to serve on 5G network in our country with built-ups in the country. India has its own characteristics over the transmission network, as we have seen in the legacy. Keeping in view that transmission faculty of India planned the session for backhaul, for which our DG permitted and also kindly agreed to inaugurate the session. After his inaugural address, we will have technical session followed by question and answers. To enrich the content, eminent speakers from the industry who are deeply involved towards the development, design, and deployment of the network are here with us delivering their talk. First among them, first session will be on 5G backhaul and key transport requirements from Sri Vivek Dixit, GM Network Solution Direction. With more than 18 years of industry experience, Mr. Dixit is expert in telecommunication, transport network, data center solution, and mobile packet backbone network domain. He is currently working as GM Network Solution Direction with market area of Southeast Asia, Oceania, and India. His expertise domain expanding from cutting-edge product and technology like IP MPLS, enterprise and data center, mid-haul backhaul solutions, designing, software-defining SDN and NFP. Next session will be from Rahul Puriji, CTO and governed an emerging business from Nokia Networks. He'll be talking on wireless and optical backhaul transport evaluation. Sri Puri is working with Nokia as CTO for government and emerging business. His key strength includes multi-domain knowledge in radio, core, cloud, transport, IP, security, and much more. Has more than 26 years of experience, including 11 years of international experience. Previously has worked with various roles related to strategy, technology, planning, operations, solutions, pre-sales. We'll have interesting session from him along with Mr. Dixit. Third and concluding session will be from Neha Satak Madam. Will be delivering on E-band wireless backhaul and integrated access and backhaul both. The solution will be from Strong. Madam is senior entrepreneur with more than 15 years of experience. She holds a PhD from Texas A&M University and Masters in Aerospace Engineering from Indian Institute of Science, Bangalore. Prior to Strong, she co-founded two space companies, Space IOM and ICAPS USA. She is a recipient of number of awards and grants, including the Amelia Earhart Fellowship and WUQ Fellow. So, based on the topic, we have requested them to enrich industry with all happening on the backhaul side, and they are happy, and we welcome them. They agreed to join us and give us excellent talk on the topics. Not taking much of the time, may I now request DG NTI Sri UK Srivastava sir for the welcome address. Over to you, sir.
Thank you very much, Sinaji. Officers from LSAs, Telecom Engineering Center, DOT headquarters, CDOT. I see Dr. Pankaj Dalila has joined, Director CDOT. Officers from BSNL, MTNL, TRAI, Academia, and my fellow officers from NTI-PRIT and other DOT units. Eminent speakers, Mr. Vivek Dixit from Ericsson, Mr. Rahul Puri from Nokia Networks, and Madam Neha Satak from Astrom. Good morning to you all and welcome to the webinar. Ladies and gentlemen, we have chosen a hot topic for today's webinar, that is latest trend in cellular backhaul system. All of you know that the desire for more and more data during mobility is driving the cellular networks to deliver more. And then there are applications of low latency services, for example, connected cars and remote surgery, that are changing the performance characteristics of the existing backhaul networks. We all know that 5G is a game changer, bringing a host of services which were only in the confines of imagination previously. Whether it is remote surgeries, autonomous cars, smart grid, or factory automation. 5G operates at a higher frequency spectrum, which results in increased number of base stations. The traditional RAN architecture houses the baseband unit and remote radio units in each cell site. In 5G, the RAN architecture is split into front haul and backhaul, all of us know. And the front haul is the link between the controller and the radio head or small cell. Apart from wireless upgrade to new radio technologies, one core infrastructure, the fiber optic wireline networks, also needs to evolve to meet the stringent demands of the 5G networks. The wireline transport network is the bridge between the services and subscribers, which also needs to scale to meet the 5G constraints. The recent commercial deployments of 5G is in the non-standalone version that is built over the existing 4G LTE infrastructure. The requirement from the transport network in this case is only to provide higher bandwidth for enhanced mobile broadband, that is EMBB applications, such as ultra-high definition video and real-time gaming. Now, this was achieved through increase in the mobile backhaul capacity of the network. But the real challenge comes with introduction of 5G NR, that is phase 2 of this 5G thing, 3GPP release 16. There are arduous performance demands on the transport network with increased speed, latency, number of connected devices, and synchronization requirements. Situations with high bandwidth required hotspots such as stadiums, computer hubs, office, huge apartments require centralized baseband deployments. The new applications necessitate re-architecture of the mobile backhaul transport to support either centralized RAN or virtualized RAN architecture comprising of converged solutions for backhaul and fronthaul to meet the lower latency and synchronization requirements. Will be around 9.8 billion. And in terms of different RAN technologies, LTE subscriptions were at 2.86 billion in 2017. That will be around 4.24 billion, total 43.43% of overall connectivity by 2025, whilst 5G subscriptions will be around 850 million by 2025. Similarly, there are projections of IoT devices also. So therefore, the backhaul strategy evolution must cope with both an increase in subscriptions as well as large number of those subscriptions being high bandwidth users. Now, despite fiber being the preferred choice for the operators for 4G, 5G backhaul, microwave backhaul is the most used technology due to a combination of its capability and relative ease of deployment, making it a low-cost option that can be deployed in a matter of days. Most operators rely heavily on microwave backhaul solutions in the range of 7 GHz to 40 GHz band. In addition to higher microwave bands such as V band, 60 GHz, and the E band, 70/80 GHz band, about which we are going to discuss today in more detail. The backhaul links using V band and E band are well suited for supporting 5G due to their 10 Gbps to 25 Gbps data throughput capabilities. The microwave can be used for line of sight and near line of sight modes, which makes it ideal to be used in chain, mesh, or ring topologies to enable resilience and reach. So the main drawback is that, of course, microwave backhaul requires a license, apart from V band that is unlicensed in most of the countries, not in India so far. And to a lesser extent, the E band, which is light licensed. It is also possible to combine low frequency microwave bands with high frequency microwave bands to achieve high capacity over a long distance with enhanced availability. Further, 5G new radio introduces a new type of wireless backhaul known as integrated access and backhaul, about which the speakers I'm sure will be talking about today. And it's of particular interest for dense deployment of street level radio nodes, etc. Ladies and gentlemen, Mr. Raju Sinha, DDG, and Mr. Subhash Kesarwani, Director, have worked very hard to bring this team panel of speakers to this webinar. I once again welcome to all the three speakers with core of my heart. They will be addressing all the issues I mentioned in detail. I'm sure that you will all benefit from the discussions here today. I wish that you all have a fruitful time participating in this webinar. Thank you very much. Back to Mr. Sinha.
Thank you very much, sir, for blessing to the seminar and excellent speech. You have set the tone for the seminar for increased backhaul capacity as the network emerges, and given food of thought over the use of radio, optical, or mix of both in the emerging network of 5G and more. I'll now hand over to my director, Mr. Subhas, for further moderation. The speakers. Over to Subhas.
Thank you, sir. So let us start our session. So I would request our first speaker, Mr. Vivek Dikshit, sir. So please, over to you, sir. You may start your session, sir. Please, sir. Shri Vivek Dikshit, sir.
Hello, good morning, everyone. I'm Vivek Dikshit from Ericsson, and thanks a lot, Subhash sir, Srivastava sir, and Raju sir, for giving me this opportunity. And I think, as rightly said by Srivastava sir, this is one of the very hot trend today about the cellular backhaul system, which everybody is working on. We know that 5G is already there, across many countries in the world. And now it is the time that India should be prepared for the same. So we also need to look at whether the transport system or the cellular backhaul system of the India is ready for the 5G or not, and what are the challenges and what are the key requirements. So I will start with my presentation with main agenda. Will look at the market trends, that how the 5G is impacting across the world, across the countries. Although it is not yet in the India, but we have a lot of data available from many countries that how it is impacting. What are the main challenges it is posing towards the transport backhaul system? And what are the key requirements that need to be evolved in the backhaul system to make it 5G ready? What are the different advanced technologies that need to be considered? So this is what I would be on a very high level covering about in my session today. So looking at the market trends, as some figures have already shared by Srivastava sir. So here is some more details from the Ericsson Mobility Report, where we look that by the end of 2027, there should be around 4.4 billion 5G subscriptions, which are expected to come across the globe. And already by end of 2021, we are seeing around 660 millions of subscription, which is already there across the globe there. And this is going to be the dominant mobile access technology in future very soon. So all the data, all the traffic which 4G, 3G, 2G together have brought on the world as of now will be superseded by multiple times by 5G very soon. So if we look at the traffic data, in this slide, then we can see that we are talking about some exabytes of traffic per month when it comes to 5G. And soon what we are seeing is that, in next 5 years, the 5G traffic will be almost same or maybe higher than the 2G, 3G, 4G combined traffic which they will be bringing. So if it is like, 100 exabyte per month for 2G, 3G, 4G, it will be more than 100 for the 5G that would be coming. If we look at the application spectrum, then definitely video is the most prominent application today, and it is going to be there in the future as well. Apart from other applications like social networking, web browsing, and audio, which will also bring some of the traffic on the backhaul. But primarily, it will be dominated by the video traffic. Right, so the backhaul system need to be designed to take care of these applications and their specific SLA requirements. Let's look at the 5G evolution. Now we know that LTE evolution has already penetrated a lot in India, and we are on the inflection point here, where 5G on the mid band is going to come very soon, maybe probably this year, and then we will expect 5G on the high bands also, in future there. So what will be the change? So starting from the coverage part, we see that the low bands, which are sub 1 gigahertz, and the mid bands, which is between 1 gigahertz and 2.5 gigahertz, are already available today with the 2G, 3G, and the 4G introduction there. What we are expecting a new band is a mid band, which is 3.5 gigahertz to 8 gigahertz with coming of the 5G there. And in future, probably the high band of 24 gigahertz to 40 gigahertz will be further used for the massive MIMO kind of applications in the 5G. So what these high bands require is a very high capacity and ultra low latency. So this is the kind of requirements which they will be putting onto the backhaul network. From the RAN architecture perspective, today it is mostly the distributed RAN architecture where the baseband and the radio are together at a site. But what we are looking at in future with the invent of 5G would be a DRAN or a CRAN, which is centralized RAN, where the basebands could be centralized at one hub location and the radio can be spread across the campus to multiple kilometers. It could be an elastic RAN or a virtual RAN kind of scenario as well, where the baseband and the platform functions are mainly virtualized. It is all on the servers. So these are the different architectures which we look forward with 5G coming there. And on the transport requirement, if we see today, the maximum traffic at a per site level is something around 1.5 Gbps, but it is supposed to go up to 5 Gbps with 5G coming on there. And the interface on the baseband towards the backhaul is typically multiples of GE ports currently, but it will be expected to have a minimum of 10G in future. And with 5G high bands, probably it might be multiple of 25G as well. From the synchronization perspective, mainly frequency synchronization was there till now. But with 5G, the time and phase synchronization will become very important. And since this is very critical, I have some detailed slides coming on the synchronization part also. And from the backhaul or the transport technologies, as Mr. Srivastav also said, that microwave and fiber are the two dominating ones. Fiber, definitely the penetration is increasing in India now, but microwave anyway is reaching at all the places to cover the last mile connectivity. So they will continue to be there along with IAB, as he mentioned, that IAB would be another backhaul technology that we will be looking forward. And from the interface perspective, front haul is now introduced in 4G as well with CPRI. With 5G, we will be looking at the CPRI or eCPRI interfaces for the front haul. So if we look, there are so many changes that are coming from LTE to the 5G evolution on the transport backhaul side. So how the backhaul is getting ready for these challenges is something we need to see. So let's look at the challenges. Now, 5G will be mainly driven by the use cases, as we all know. So we talk about, automotive use cases or entertainment, gaming, VR, and, enhanced mobile broadband or smartphones, smart homes, shopping and immersive communication. So these will be the different advanced use cases that we would be looking forward in 5G. And each of these use case will have a different requirement in terms of capacity, latency, reliability, and security. So the 5G network need to take care of all these SLA requirement of each of these use case in the transport network as well. So that is the biggest challenge, that how the shared infrastructure can take care of the different SLAs. And there are different technologies for that, like network slicing, which we'll be talking in the coming slides. So what we need now, it is very clear that 5G transport has to be ubiquitous in nature. That means it should be able to connect to any kind of the RAN architecture, maybe a DRAN or a CRAN or a VRAN or a ERAN. It can be any kind of architecture in the RAN side. It can be any interface. The transport is the bridge between the radio and the core, and it has to be flexible enough to take care of all these technologies, challenges which are coming up, and which is vast difference as compared to the 4G, which we have seen till now, which was quite a flat architecture there. So if we talk about 5G RAN architecture, so what is the difference? So if we see like in the distributed RAN, where the G node B and the radio are combined together at one side, probably the NG interface is the 5G interface, which we are going towards the backhaul. And there will be XN interface, which will be X2 or other XN interface towards the other basebands. But there will be further architectures of CRAN where multiple basebands will be combined, clubbed together at one site, at one centralized hub site, connected on the CPRI or eCPRI interfaces to the various radios spread across the geography. So this is another architecture that will come. And then there will be E5 interface, which will be talking between the various basebands there as well for RAN coordination features. So new interfaces are coming up. And as we talk about the baseband platform function virtualization in a virtualized RAN architecture, the new F1 interface will also come when we talk about the mid-haul networks. So the mid-haul network introduces new interfaces there as well. So the E5, F1, X1, NG, these are a lot of new interfaces and new requirements that 5G is going to bring, and that need to be taken care by the transport or the backhaul architecture. So now I think we are very clear on the different challenges. If we summarize the various challenges, we can see that the key drivers for transport evolution towards 5G is mainly the bandwidth when we talk about the new spectrums in NR and the new coordination services and the new radio technologies. More number of connections which we are talking about. So the small cells will increase, massive IoT, critical IoT, different kind of connections will come, and the high security requirement will be there, from the regulators and looking at the global threat as well. In terms of latency, it is going to be further lower down. The requirement will be a further lower, latency for critical IoT services and the RAN coordination services, and a very low jitter or latency variation will be expected. There will be new interfaces which we have seen, and new concepts like slicing. The network slicing or end-to-end slicing is the new concept which will be introduced to meet the SLA requirement of the various 5G services which we'll be talking about. And then sync is something which will remain same, which is there today as well, and that will be there tomorrow as well. So the superior RAN performance, it implies a superior transport network. So if we are looking for a better throughputs through the RAN, definitely we need to look for the superior transport network, which can take care of all these things. So looking at the key backhaul requirements, this is an end-to-end IP backhaul picture which you can see. So you can have various kind of a mobile broadband or a fixed broadband or an enterprise kind of services, which will require a last mile connectivity to the different devices. Maybe an access router or a CP kind of connectivity. Further, at the last mile, you may find it different, but it will further converge at the aggregation layer. So all the services will converge together at the aggregation layer. And then we are talking about a converged edge or a EPC, the evolved packet core, which will have all the various services or the applications running here on the virtualized environment. You have the IP core, which will be connecting the various data centers together, and the capacity requirement, performance requirement of the equipments or the routers will increase as we move from the access towards the core. So this is how the capacity, like we are talking about 10G and maybe 25G capacity in the last mile itself. So obviously the aggregation would be talking about 100G, and the core we will be talking about 400G kind of capacities. So this is the evolution that is happening in the IP backhaul network. But if we talk about specifically 5G, what new it is bringing, so these are the 5 pillars which will be defining the backhaul network's performance. So how robust is the sync architecture? How much capacity is available with flexibility there? The quality of service which we can provide to different services, the security which is available, and the kind of converged network architecture which is there. So I would primarily focus that if these 5 things are properly designed and taken care, we can really say that yes, our transport is, or our backhaul is 5G ready backhaul. Now, why sync is so important, and what are the different kinds of sync we are talking about here? Let's take a little deep dive here. So these are the 2 clock signals which I have taken here as an example, and you can see that FA frequency is not equal to the frequency B. So we can see the gap here is much higher as compared to the here. So the frequency is different, and the time is also not aligned, right? So we'll say that there is no synchronization between them. When we talk about the frequency synchronization, at least the gap between the peaks for the two signals is the same, so the frequency is same, but the time are still not aligned with each other. So this is still okay, because when we talk about the edge HSP or LTE, the frequency synchronization is sufficient, and this is what we have been designing till now using the Sync-key or 1588V2 or different technologies. But as we move towards the 5G TDD or 5G COM, the
I think we lost him.
Yes, sir, we are just checking.
I have to reconnect.
Mr. Dixit, I think you need to reconnect, please.
Hello, sorry. There was a power cut, so just give me 2 minutes. I'll connect back.
Okay. The power.
Hello. Yeah, I'm back. Sorry, there was.
We are able to see you. Please share this screen.
Yeah. Sure. Uh, Let me know if you are able to see the screen.
Uh, Not yet. Yeah, it's coming on the same frequency phase time.
Okay, great. Yeah, sorry for that. So, as we were discussing about the frequency synchronization, right? So that was good enough for LT. But as we talk about the 5G, then probably the phase synchronization and time synchronization will also become very important. So the time synchronization, we can see here that even the peaks are aligned and the frequency is aligned. So there we can say that yes, it is time synchronized. So this is what probably we'll have to look at it. And there are various profiles, for the timing synchronization that are available from ITUT. So, 8265.1 is there for frequency synchronization, which has been there from long. Uh, but then from 2016 onwards, we have G.8275.1, which is a full timing support, or FTS, which we call it. This is available, which requires that all the nodes in between the path should regenerate the timing packets, right? So this is considered as a full timing support and a very accurate time synchronization profile, which is a recommended profile as well to implement. But since it requires all network nodes should support this, probably there is a chance that some network nodes are obsolete, or they are purchased much before 2016. They don't support this. So they have another profile, which is 8275.2, which is partial timing support, which says that okay, we can, if we have some equipment in between which do not support a full timing support, then also we can pass on the clock signal or the synchronization signals transparently across the end equipment. And there is also assisted partial timing support, which has a backup, where GNSS is the main primary source, and then we have a network support as a backup support. So these are the four different profiles which are there from 2016 onwards, which is recommended for 5G implementation. Just to give again a graphical interpretation for the same. So 8275.1 requires that every router in between the path from the grandmaster clock to the radio should be PTP capable. That means 802.15.1 capable. If there is any non-PTP capable device in between the path, then the sync will not forward, right? So this is very accurate, but this has this limitation that the network has to be updated. Now, as we know, hello. Hello.
Audio is again freezed. Mr. Dixit. Audio is not
Can you
coming.
hear me now?
Now it's okay.
And you can see my screen as well.
Not yet. We are just waiting for that.
One suggestion, Vivek,
No,
I
it's
think
coming.
there's a bandwidth constraint. If you can switch off your video, I think that will help you.
Sure. Okay. Let me know if you're able to see. We can start.
Yes, we are able to.
Great. So as we were discussing that, G.875.1 is the most accurate and the preferred timing profile for the time and phase synchronization, but it has a limitation that it requires every equipment in between to support this feature. And in case if the network has some equipments which are old enough and which do not support it, then it becomes a problem to implement. So that's where partial timing support G.875.2 can also be implemented, which takes the clock signal from the grandmaster up to the baseband transparently across all the nodes. So that means the in between nodes need not to be the PTP capable, and if there are multiple non-PTP capable devices as well, then also this can pass through. So I think these two technologies are, very good recommended technologies for the time and phase synchronization for the 5G. That every operator need to see that their network is evolved to support these two technologies or not. So as a summary for the synchronization, we see that Syncy has been there from long time for the frequency synchronization. We also use NTP as a primary, for the packet layer. But when it comes to time and phase synchronization, it is mainly the PTP which is used. So GNSS or a GPS device is, at a local site is definitely one of the, most preferred option today. But it has, of course, high cost because you need to deploy GPS at every site. But as a backup, you can go for, GNSS plus full timing support FTS, so that you have a backup in case if this goes down, then you have a PTP support also there. And of course, there are GNSS plus APTS or FTS plus APTS. There are multiple options which can be deployed by the different operators to make their network time and phase sync ready. So operators can choose any of these technologies to make the network ready. So that was on the synchronization and capacity, as we already discussed that, as we move towards the core, the capacity requirement is now increasing from multiple of 100G to maybe 400G. And the new trend which is, coming up is IP over DWDM. So there again, we can use the add drop filters for the better fiber utilizations, and we can take multiples of 100Gs or 400Gs across the core networks, across the core routers as required. So again, this is one of the key requirements from the core network perspective on the backhaul, that the products or the network or the technologies should support IP over DWDM in order to expand the capacities as required. Quality of service is something which is, again, as mentioned, will be very critical. because we were talking about plain vanilla internet services till now. But as we have seen that 5G will, bring up a lot of EMBB or URLLC services, which has, low latency or ultra reliability kind of requirement. So in that means different services will have different requirements in terms of SLAs. So a traditional quality of service may not be sufficient. So in a traditional QoS, we used to have different queues, and one queue is assigned to one customer. But now, since each customer has multiple services, we further want to differentiate these customers and then the services for each customer as well. So the concept of hierarchical QoS is very important in the backhaul network, where your network should be able to further differentiate the services for each customer based on the CVLANs or the SVLAN tagging which is available, and you can go up to 2 level, 3 level, or 4 level HQS as well. That is required from the 5G perspective. So this helps you to differentiate different customers, and then for each customer you can further differentiate different services and provide the quality of service as required by each service. So this is another very key technology that is required in the backhaul network. Security, as we know that we are talking about millions of connections in the 5G. It will be multiples of the small cells. So what is secure and what is not secure is a very much open debatable topic. So what we can assume is that the transport network which is deployed by an operator and its core network, we can still call it in a trusted domain, because it is something owned by the operator themselves. So they have the required security features there. But when we talk about the actual radio nodes, the small cells which are deployed in the publicly accessible locations like malls, or maybe on the highways, or maybe on the streets. So these may come up end up at a untrusted domain, which are leased locations or not completely owned by the operators, and so they are definitely vulnerable to different security threats. So there, the IPsec, or any kind of security gateway, a distributed security gateway kind of requirement becomes very critical, where you can ensure that the last mile connectivity is also secured. So one of the way which Telstra in Australia has deployed for their 5G is using IPsec connectivity from their cell site router, and using cell site router as a distributed gateway. They have connected the IPsec tunnels up to each of the small cells and the baseband nodes to ensure that the last mile is also fully secured. So apart from their transport network and core network, they are also looking at very seriously at the security of the last mile connectivity. So I think this is also an important thing which every operator in India should also plan before they start deployment of the 5G. From the technology perspective, we know that MPLS is one of the most common and mature technology which is used in the backhaul networks, and this is now getting extended up to the cell site router level as well. So when the 5G comes with the 5G baseband and the cell site router at the site, then the MPLS, or the multi-packet label switching technology, gets initiated from there itself. So the cell site router will basically, what it will do is, at the ingress packet, uh, it will push a label there, and then that label will be swapped across the various routers. At the end, it will be popped out. So the end-to-end, the communication happens very securely, and MPLS is known for its reliability. We can achieve less than 50 millisecond convergence time as well, in case of any route is cut. If there is any fiber cut or any route failure, then it can easily reconverge to another path within 50 milliseconds. So this has been there as a very mature technology, but now the technologies like segment routing is also becoming very popular across the globe. Now, segment routing is also known as the source-based routing, where at the source router itself, we define the segment the packet is going to follow. And that segment, is defined based on the requirement of the service, whether it requires a lowest, shortest path, or a path which is which has higher bandwidth or which has a low latency kind of requirements. So how it is different? So going towards segment routing, there are two paths available. So you can use an existing MPLS segment labels as well. So the existing MPLS network can be moved to MPLS segment routing, or you can have an IPv6 based segment routing as well, which is called as SRv6 also. So here we don't require MPLS at all. Uh, on the control plane, of course, you can do the routing protocol with extensions at the routers itself, or you can have a common control plane using the SDN controller where you can push. So segment routing makes the deployment of SDN controller very easy, and that's why this is one of the preferred technology nowadays by all the operators. But on the data path, I think it remains same, that they do the shortest path computation and or the explicit path computation and using the IGPs, and then send the traffic there. So this is new technology which all the operators are now adopting above MPLS to make sure that they meet the requirements of the services and have a better control over the services. And SDN, of course, software-defined networking is one of the technology which has been much talked about and also implemented very well by many operators worldwide, and even in India we can see. And basically, it talks about the control layer, coming together on a server here, a common server from where we can control the end-to-end path of the packet. So we can actually do the control processing. We can put it on a server there, and we can make the router free from the control plane, and the router only has the data plane, so it only does the packet switching. But the complete calculation of the path, the shortest path calculation and the PSAP calculation, all these are done at the SDN controller level. And this is now becoming more and more RAN aware, and more automation is something which is expected out of it. So this is a continuously evolving field, which is very important when we deploy different services. And last but not the least, the network slicing. This is also conceptually discussed many times, but now I think with 5G it will very soon become a reality. We will the network into multiple slices. That means a common shared transport infrastructure will have slices. Each slice will take care of each application that will be required. So maybe EMBB will have its own slice, and then when we say a slice, that means all the resources will be distributed, according to the requirement in each slice. So what are the various steps of a transport network slicing? Would be how you are partitioning your resources, how you are isolating those resources so that the slice 1 resources are completely isolated from slice 2 resource, how you are aligning these slices with the RAN and the core, because slicing is a concept which is not just for the transport, it is an end-to-end concept. If you have to provide a new slice for a new FWA service, for example, it has to be end-to-end, and I think RAN and core, everybody is talking about slicing now. So this is again new concept. There are various technologies to do so. Using HQS also it can be done, using segment routing, traffic engineering, tunnels, as well as some hard technologies like Flexi and other are also coming up for the same. So in summary, if I talk about Ericsson's experience, we have the most highest 5G deployment experience worldwide. So in the 46 countries, we already have 97 live 5G networks and 149 5G commercial agreements. So across the globe, we are working with various operators on the 5G at different stages. Some you can see the purple dots which are there are the high band deployments of 5G, and mostly the green ones are the mid bands and the blue ones are the FDD bands. So for the different bands, different technologies and different operators, we have a very wide experience of 5G deployments. And most of these 5G deployments are using Ericsson Router 6000 portfolio, which is completely 5G ready. We have various products which are ready in terms of synchronization features, as I discussed, time and phase synchronization, in terms of QS or network slicing features, in terms of segment routing features, in terms of security features. So all the features required for 5G are fully available, and the capacities, if we talk about, we have starting from a small 30 Gbps capacity up to 2.7 terabit capacity. We have various products in the different ranges. And not just the routers, Ericsson has the complete portfolio for the front haul solutions and the microwave mirroring solutions as well. So in a summary, I would say that India is now ready for 5G. We have with the global experience, we know that what are the requirements in terms of backhaul network which need to be taken care. And I think those things we are already discussing with the various operators. We have done the successful 5G trials also with Bharti, Vodafone, and other operators. So, so this backhaul technologies are getting evolving because it takes time. So it is not easy to evolve the network, so fast. However, with the right knowledge and right technologies and right products, I think we are ready for 5G. This is it from my side, and I'm open for any questions, maybe now or at the later stage as per the plan. Thank you.
Thank you, Vivek sir. So thank you for a very nice talk. And since audience here are from different backgrounds, so just let me summarize what he told in a very layman language. Because this webinar is open to students also, and so many students and from engineering students also they have joined. So just I will give you an analogy that what sir has told, that we have bought a very good quality car and now we are going to prepare a good road for that. So 5G is a good quality car that we have purchased. Now we are talking of the road where we will move this car. So this is all about this backhaul connectivity, means we are preparing the roads. So this is for students, and thank you very much, sir. And now I will invite our next speaker. Achha, before inviting our next speaker, just let me, I request all the audience to please hold your questions, and in the end we have question answer session. You can write your questions in the chat box. We will take all the questions with the speakers in the last. So please, if you have any question, write in the chat box. We are continuously monitoring your questions, so we'll write and present those questions to speakers. So let us welcome, let me welcome the next speaker, Sri Rahul Puri sir. Sir, please, Rahul sir, please, over to you, sir. So,
sir, good morning to everyone. I hope I'm audible and my screen is visible. Am my screen visible?
It was visible, but at the moment no.
Just let me try
Please
again.
try to share.
Is it visible?
Yeah, it's visible now. It's better that if you mute your video part, there will be no problem of bandwidth.
Yeah, I will switch off my video. Just let me switch off my video because I think there is some bandwidth constraint.
Yeah.
So I hope it is fine now, right?
That's great.
So first of all, I want to thank Subhash sir, Srivastava sir, and Raju sir, and the entire NTI PIT team for inviting Nokia for such an important event. Now, I am part of these kind of industry events from last 25 years, and I've seen in the era of 2G and 3G. These events were more focused on radio coverage. That was the main area of discussion. In the last 4 or 5 years, when 4G is around, new applications, new use cases, people start talking about packet core, the capacity. So that was the evolving part. But then from last 1.5 years, when the 5G is a hot topic, the discussion is very much on transport, and rightly said, by Subhash sir, it's the good car we have purchased, and if there is no good road, you cannot drive that good car fast. It will be moving like an old car. So transport is a very, very important part of the entire 5G ecosystem. Now in the various forums, we have talked about how the new use cases are evolving. Use cases like which needs high throughput, use cases which needs low latency, like Srivastava sir talked about remote surgery. So these kind of use cases are the drivers. But today my main focus area of this presentation is how these new use cases are actually changing the mobile network architecture, and how transport network has to evolve to address these kinds of new requirements. So just to start with, let me just also put the pointer because there are, yeah. So there are various different drivers which are changing or evolving the transport network. So the unifying driver among them is the expanded portfolio of mobile and wireless services, which were enabled by the mobile innovations, which is 4G in the past, and now in the new era it is 5G. So the radio network or the radio access network need more bands, which because of the new use cases, and bandwidth, which will add or need the new RF capacity. And to ensure maximum coverage and spectrum efficiency, 5G also supports massive MIMO, densification, and new BBU functional splits. We know about the cloud RAN, the DU unit, the CU unit, and the RU unit. So we'll talk about that in the coming slides. But these are the main drivers, the new changing happening in the 5G network. And we also talked about front haul, mid haul, and backhaul. So in the past, in 2G, 3G, we just talked about backhaul, but now the concept of front haul, mid haul is also very prominent. And in the coming slides, we'll talk about these concepts also. So 5G also is designed for cloud architectures, whose agility leverage network slices to deliver flexible and efficient broadband services to consumers and vertical industries. So every slice needs a different KPI, different throughput, different latency. So that is also something which is required, which we need to address through transport. So the combined impact on mobile transport is huge. Connecting radio sites in more diverse locations to the mobile core has always been a challenge and become more in 5G now. So connections must support a 10-fold increase in throughput because of the use cases we are talking about. Along with LTE, we'll stay for some more time. So it has to handle LTE also, and to support new services. So 5G networks are bigger than LTE and will interconnect a massive increase in networking nodes and endpoints. So we will not connect people, we'll connect things also. And when we say things, some of the research says the count of Internet of Things will be in billions, maybe 4 or 5 times than the subscribers we have. So for example, today we have 4 or 5 billion subscribers. We are talking about connecting around 20 billion things. So we have to connect a lot of things, on this network. So, so the impact on transport is significant. We need more sites, we need more radio sites which require connectivity, and connectivity at least an order of magnitude greater than LTE, that we know for sure. The millimeter wave radio units will require massive front haul capacity, even with eCPRI. And we'll talk about what is eCPRI, what is CPRI. Furthermore, providing network-based timings will be a huge cost saver. So we have to provide, the sync feature, which one of my friend Vivek has just talked about. So that is also something which is required, because GPS is one of the option, but then that is not cost-effective option. So we will have more spectrums in the mobile network. There will be RANs split in the architecture because to handle the new use cases which needs low latency. We'll talk about these things. Cloud architecture, again, the core in the old days was more centralized. Now core has to be more distributed. The user function has to be more near to the user, and the network slicing. So these are the four drivers, which is actually changing the architecture of a mobile network. And to address these four requirements primarily, there is new transport requirements which need access and capacity, time sensitive networking. Why time sensitive? We will talk about it. A dynamic any-to-any connectivity. So so there are use cases which need very different kind of requirement from transport. It is not access to core, but it is any to any. So that is something which is required because of core cloudification. And we need automation and orchestration in network, because today we are selling SIM card to retail subscribers. Tomorrow we will sell networks. We will sell a virtual network to an enterprise, to, for example, home ministry, to maybe to finance ministry, a different to a bank, to a transport company, to Delhi Transport Corporation in Delhi. So we will be selling networks to different organizations, and to be agile to address these kind of requirements, automation and orchestration of the transport network is a must. So just to move on, so the network is evolving, so the transport is also evolving. So modern transport networks are evolving to address two primary requirements. So the first one is any haul. The evolution of backhaul now is a fusion of front haul, mid haul and backhaul. So we need a cost optimized and purpose built solutions that collect and aggregate RAN or other access point traffic and bring it to the edge cloud. So why we need edge cloud? We'll talk about that also in the coming slides. And the second driver is the dynamic cloud interconnect. So inside driven IP and optical wide area networking solutions for the interconnection of distributed and cloud-based mobile core functions. That means, we need a automated, secure and high performance interconnectivity among clouds. So there will be different clouds. There will be an edge cloud, there will be regional cloud, there will be central clouds, and these are all required to address the new use cases. So we need interconnectivity among clouds, different network functions, because as of today, every function is a different box, but tomorrow it will be a virtual function or a network function. So we need to connect them also. And the applications, because end of the day, you build this network to connect to applications and serve the various users for different applications. So common across both is transport network automation. It brings the flexibility and dynamism of the cloud to provide the necessary connectivity, automation mechanisms, and extraordinary quality of experience. Now, as we said, every different use case need different SLA and KPI. So we need a very strict quality of experience for different users and different things. So, today in 4G or 3G, connecting a subscriber for voice data, it is fine. But then tomorrow when you connect industry, when you connect a machine to machine, they need very strict SLAs. So we need to have extraordinary quality of experience, which can only be possible by automation and orchestration. Now, we talk about different bands in in the previous section. Now 5G supports more bands. The macro radios on the left side here deployed today are below 3 gigahertz, as is shown on the left side. These lower bands have better penetration characteristics. They are good in coverage. It has high mobility and reliability. These bands are in the function of a fragment function of 20 megahertz blocks, and carrier aggregation is also used. So they need a bandwidth of around 1 Gbps per second for these kind of bands. If you go on the right side, there are mid bands and high bands, and these bands are used for massive throughput, and these bands have very low coverage area. So densification is something which is also required. So a mixture of transport technologies will be required to address these kind of different bands, because they are very diverse. On one side, you need you have sites which are not very dense, but then on the other side you have sites which are densely populated, in the volume of 100 cells per kilometer, which is very huge. Yeah, this is very theoretical, this will not happen in India, but then it will be very near to this. So the transport network has to be designed for all these three type of bands, where the requirement is very different for different bands. Now, if you talk about RAN function splits, how these things are happening in RAN. So we hear a lot about term front haul, mid haul, and backhaul, and they're all related to RAN architecture and how functions are physically distributed. So let's talk about LT. The two primary deployment models of 4G RAN are centralized RAN, where you can see the BBU is getting pooled in a common area, and a distributed LT architecture where the BBU is actually there in a dedicated radio site. So again, an advantage and disadvantage here in the BBU pool architecture, some of the resources can be clubbed for different sites, and this gives advantage in terms of footprint of the sites. It gives also less power. You can have the inter-site handovers are also managed very easily if you have these kind of architectures. Now, if we move to the 5G side, again very similar. In 5G, the architecture is splitting the BBU in three different locations. So you have the low level of the BBU functionality at the radio site at the RU location, and then you have the mid level of the BBU functions at the DU location, and the non-real-time functions, which doesn't need a very low latency, are there in the CU unit. So if you see here, that split is there on the left side, very clearly mentioning. So the eCPRI, or the lower layer of the radio, is a solution designed to improve the performance cost equation of RF performance and transport cost. So the eCPRI is actually used to reduce transport bandwidth tenfold by moving BBU low layer functions into radio unit. It also uses Ethernet, and thus open up opportunity to use more than just the photonic layer. But that comes with the caveat that since the lower layer split does not relax the latency, the new specialized Ethernet technology, also known as time sensitive networking. And in Nokia, we have very specific products which can handle these kind of time sensitive networking units. So just to further drill down the various architectures. So if you see here, within 4G and 5G, this is the classic distributed RAN where all the three units, RU, DU, and CU, are in the radio site. And then the next, and we have a backhaul connectivity which goes to the central cloud. Now coming to the 5G, it is moving to distributed 5G cloud RAN, where CU is placed in a regional cloud, and we have a mid-haul which have a connectivity between DU and CU through an interface known as F1. Now further, to have more centralized architecture, have less footprint on the radio side, it is further split into a centralized 5G radio where only the RU is there at the radio site, and DU is placed on the edge cloud, and CU is placed in the regional cloud. Now, there are very stringent requirements to connect RU with DU because it supports CPRI. It needs something around 200 microsecond of latency, round trip latency, and if you talk about the speed of light, which is around 5 microsecond per kilometer, so on in one direction. So if to achieve that 200 microsecond delay, maximum distance between RU and DU could be 20 kilometers. So we can have a edge cloud away from the RU unit for around 20 kilometers. Initially, CPRI was introduced in 5G, where the requirement was very stringent. As I said, 200 microsecond, and every sector was requiring around 10 Gbps throughput. To address these kind of requirements, only optical solutions, are possible to address these kind of requirements. But with evolving CPRI to eCPRI, these requirements are relaxed, and now they are in the range of milliseconds. And also the throughput has been reduced from 10 Gbps per sector to I think 2 to 3 Gbps per sector. So that is something which is evolved, and as the main driver for this evolution is have pool resources, have better intersite synchronization, and have less capex in terms of site footprint. But then these kind of requirements add new transport requirements where you should have very, very different flavors of transport. So in the old days, we have only microwave or fiber for a site to connect. Now these backhaul architectures has changed to front haul, mid haul, and backhaul, and I will show in the coming slide that how different flavors of transport technologies like microwave, like OT and OLT, like optical time sensitive devices can fulfill these requirements. So it is not a simple solution in 5G for transport where you just need a microwave or a single fiber. It is different flavors of transport technology which will address these kind of different requirements. And again, as I said before, 4G will stay for long along with 5G. So we also need to address the CPRI requirements of 4G. And there's a protocol known as radio over Ethernet, which can be used. And we have solutions which are time sensitive networking solutions, which support both these protocols and can address the requirements of centralized 5G cloud RAN and centralized 4G RAN. Now we have talked about radio a lot, let's talk about core also. So we said there are requirements in 5G where we need very low latency use cases. So we are now moving into a CUPS architecture for core. What do you mean by CUPS architecture? It means the control plane and user plane are not at the same location and are not in the same box. So the user plane function where the actual user data function works, can be very near to the subscriber. It can sit at the edge cloud. So you can have a packet core UPF user plane function of 5G sitting at the edge cloud. It can also sit parallelly at the regional level, and it can sit at the central level also. But the control plane of the core network should be there in the central cloud only, because no use case need the control plane at these edge or the regional cloud locations. So why we put these user place functions in different locations? Because we said before, the network slice is something we are dividing a physical network into various virtual networks, and every virtual network or every use case need different KPIs. So there could be a gaming use case which needs very low latency, or a use case which is location specific. So that can be served by a UPF placed in the edge cloud location. So uh, from transport perspective, how it changes the transport network. So in old days, in 3G, 2G or 4G, it was a access site connecting to the core site. So it was a simple star topology from access to core. But then here it is not anymore access to core. It is any to any. You need to connect a site to edge. There should be a routing directly to the edge. There should be a routing to the edge regional cloud. There should be a routing to the central cloud, and similarly the central cloud need to connect to regional cloud also, because the control plane sits here and the user plane sits here. So it is any to any architecture from the transport perspective, because of these new concept of network slices. So what I said before, something very similar here. You can see there is a automated car, a driverless car, which needs a very low latency. So it will connect to the mobile core, which sits at the edge cloud. Similarly, you can see there is a gaming application, this blue line, which needs medium time of medium latency, so it can connect to the aggregation or the regional cloud core user plane function. And there are normal IoT like smart lighting, smart metering. They can connect to the user plane function, which is in the central cloud location. So different requirements need different connectivities, and to address them, you have to have a very smart any-to-any transport network. Now, when we talk about slice, you create a slice not only of transport, but radio and core also. So you have controllers for all these three domains, which actually create an end-to-end slice of a network. Now, we are not selling SIM cards in 5G, we are selling networks, and these kind of different slices need very stringent time to market. So to address these kind of slices, address these kind of requirements, you need an end-to-end network slice orchestrator. And it is not just the creation of slice, you also have to have service assurance. That means, you have committed a SLA, you have committed a throughput, you have committed a latency that has to be maintained throughout the life cycle. So if you create slice today, it is working fine. It has to work fine tomorrow, day after, throughout the commitment you have given to your enterprise customer. So to manage that kind of service assurance of a slice, you need a orchestrator which very well talks to all these three controllers and create slice and maintain those slice as per the agreed SLAs and KPIs. Now, in today's network, we know we have various vendors for every domain, be it radio, be it core, be it transport, Ericsson, Nokia, there are other vendors also which provide almost everything which is required to run a transport or a mobile network. Now, in old days, every network element had their dedicated EMS or NMS. And it was fine, it was manageable, things were happening fine. There was a common OSS layer which give you a little, FCAS functionality, monitoring, but not, a complete visibility and complete control from that OSS layer. Now, going forward, as we said, we are talking about slicing, we're talking about orchestration. That concept of dedicated NMS coupled with a dedicated network element of vendor will not work in the 5G era. We need open programmable platforms to basically manage all the components of network. We need to decouple the equipment with the NMS or the OSS layer, so that the network is more open, more agile. Why I say agile? Because the requirement of the new era is very dynamic, very quick, and the traditional way of configuring for managing a service, doing a service assurance of a service given to an end user is not doable with this kind of environment. We need to have a centralized intelligence which have a common view of the network, irrespective of the vendor, if it is Nokia or Ericsson or anybody else. The operator should have an end-to-end common view and can manage, can configure, can do a service assurance from a single window. So something, what I said before, service orchestration is the in thing. The strict SLA required to manage those network services can only be done automatically, and it has to have a common view for all the critical domains. When I say critical domains, I'm talking about RAN domain, core, and transport. So in the past, we had just backhaul, so radio side connecting to core either with microwave or fiber or a lease line. So that is no more the scenario. There are three different flavors of any haul. We call it any haul now, which is front haul, mid haul, and back haul. And every connectivity have a very different requirement. For example, as I said before, front haul needs very low latency, high bandwidth. To address these kind of requirements, there are very, very specific components or transport equipments, like a DWDM box can address these kind of requirements. And the new time sensitive networking boxes or the transport elements which are designed specially for front haul, which works on the standard of IEEE 802.1cm, low latency, high throughput, and it supports both ECPRI and CPRI, ECPRI for handling the 5G traffic and CPRI to handle the traditional 4G traffic. So these are the boxes which are more logical, more useful in the front haul scenario. In mid haul, IP MPLS box can address the requirement. A metro optical aggregation can also address the requirement. And the connectivity between the core side and the data centers, again, there are core routers, there are optical core WDM boxes and OTN also, which can address some of the low throughput or low requirement connectivity from a small data center to the central data center. And to have a common view, to have a common service creation, there should be a common controller of transport, which can actually configure all the different transport technologies from a single window, which can have the visibility, which can monitor the SLAs, which can monitor the KPIs of different transport flavors from a single screen. As Nokia, we have all these components, and I'll talk about the various products which can be placed in the various domains. And also I have a short video talking about how a transport domain controller play a very important role, not only in service creation, but service retention in terms of SLA and KPI management. So, as I said, in transport, there are very, very different flavors of technologies, be it IP routing and switching, be it optics, there is microwave also there is OLT, ONT. All these components are very usable depending on the requirements of a specific segment of the anyhow network. So from IP routing perspective, we have routers all the way from around 100 terabit per second to small boxes which can support around 1 terabit capacity. So for the core locations where you connect a regional data center with a central or aggregate data center, there are some core routers we have with different capacity, different throughput. To connect aggregation side to the access side, again we have different family of routers. So again, they are very specific for aggregation connectivity. There are some legacy interfaces still there in the network, because we see 2G with 3G are still there in some of the networks, which works on very legacy interfaces like TDM. This is a very specific family to connect those kind of legacy sites to more modern data center centric architectures of 5G. So that we cannot have a different network, transport network for 2G or 3G. The concept today is a converged network, and to manage those kind of converged concept, we should have something which need to connect the legacy interfaces also. So this family of 7705 is specifically to address those kind of legacy interfaces. And then there are also, as I said, the concept is converged network. We need to have in today's network some enterprise traffic also, because the CSPs of today's world are no more only mobile operators. They are also managing a lot of enterprise traffic. So we need to do a lot of port aggregation in cell site. So to manage those kind of port aggregation, we have a specific family which address those specific needs. From again, as I said, there are different flavors of transport. IP is one flavor, but then optics is also something which is very specific. In front haul specifically, before TSN was introduced, as per IEEE 802.1cm, optical boxes were used to address the front haul requirement, which is in Nokia we have this series of 1830 TCN boxes, which comes in two different models, support both CPRI and eCPRI, so that converged traffic can be handed over to the aggregation sites of both 4G and 5G. Again, to connect aggregation sites to the core sites, we have different optical boxes with different capacities, different slots, different throughput. These are the mid-side boxes, PSS 8 and PSS 16, which is from aggregation to the core locations, and to connect different core location or inter data center cloud locations. We have big boxes which can handle again a traffic of in the level of around 100 TBS per second. We have talked about optics and IP, but there is one thing which is also being used, and we have experienced OLT. ONT is also one of the very important factor, one of the very important technology being used in the 5G era. We in Nokia have different flavors of ONT OLT architecture. So that we have small form factor SFPs which can be inserted in a cell side router. So a cell side router can be connected to a OLT over the ONT OLT network. So again, if a CSP is having existing OLT network, it can be reused to address the 5G traffic requirements. Similarly, we have a small form factor SFP ONT, which can directly be plugged into a macro site. If you don't want to put a IP box or a optic box, and the site is very small with just maybe 5G or a 4G site, there is no traffic aggregation required. So directly that macro site can have the ONT plugged on into the site, and it can reduce a lot of form factor, a lot of the power cost, the rent cost of a site which doesn't need a lot of different technologies. And then last but not the least, we have pizza boxes ONT solutions also, which can address requirement where you have different flavors of traffic coming to the aggregation, 4G traffic, 5G traffic, or enterprise traffic. Microwave, coming into the 5G era, E-band will play a very important role. It works in the band of around 80 gigahertz, and it can achieve a throughput of 10 Gbps. So we have different models of E-band microwave. The series is UBT, and generally because it is a beam wave in these very high bands, so the antenna size is maximum 0.6 meters in these radios, and they can actually work for around 1 to 1.5 kilometers and give a good throughput of 10 Gbps. We talked about densification of radio sites. So if we have 100 sites per kilometer square and fiber is not possible in those 100 sites, for a very small area, these kind of microwaves can be a very good substitute to address these high densification of 5G sites, which are working on a millimeter wave. We also have traditional microwaves which works on 13 to 38 gigahertz, but I'll not talk about it because for 5G, the change what is happening is more on the E-band side. Rest I think is all what is there in 2G, 3G, and 4G era. So last but not the least, we talked about different flavors of transport equipments, IP, optics, OLT, ONT architecture, and microwave all play a very, very important role. But then to manage these networks of networks, not network, but networks of network, because of slicing, we need a very smart orchestration layer, which can see all this underlying technology as common and can manage them very easily, the life cycle of the services, the life cycle of all the network equipments. So I'll just play this video and then we will conclude.
In the cloud world, users consume applications and content in an on-demand fashion. However, today, they are not able to consume network services in the same way. To deliver profitable on-demand network services, network operators are faced with a few key challenges. With complex multi-vendor networks, adding new network services is slow and difficult. Network traffic is hard to predict, so extra bandwidth must be added to compensate. Service provisioning and network engineering are siloed, further limiting time to market and network efficiency. By introducing a new, unified approach to Carrier SDN, Network Services Platform addresses these challenges. It starts by simplifying and automating network services setup and adds network visibility to quickly select the best available path across multi-vendor IP and optical networks. As more services are added to the Network Services Platform minimizes congestion and maximizes resource utilization through intelligent placement of network traffic. It can also dynamically retune the network to recover stranded capacity. The Network Services Platform is the only carrier SDN solution that unifies service automation with network optimization to deliver on-demand network services quickly, cost-effectively, and with efficient use of network resources. Network Services Platform, enabling on-demand networks for an on-demand world.
So this network services platform, which is a Nokia product, which is a SDN layer which can actually support all the underlying technologies which are there in Nokia portfolio from transport perspective, be it IP, be it optics, OLT, ONT, as well as microwave. My last slide, as Nokia, we are leader in both the IP layer. We are first in the routing platforms. We are within EMEA region, and we are number 2 in service provider routing platform globally, if we just exclude China part. In optics also, we are number 2 in EMEA and the Latin America region, and number 3 overall globally. So that's it from my side. Any questions?
Okay, thank you, Rahul sir. So you have carry forward what Vivek sir started. In fact, he set to the tone for the webinar. He actually gave all the requirements he set out, and you have beautifully evaluated our existing wireless and optical network, and that evaluation has been very holistic actually. We came to know that what type of requirements we are going to have. I think 20 years before, when we used to send one email, we used to become very happy that email has been delivered. And yes, same thing, I think we are going, same happiness we are going to see in different words. Indeed, we are going to be different word. Actually, now what I feel that the word is going to be more democratic, and with this, absolutely, all will have something to say in that network. And the way you showed that our network slicing, that all the functions which network right now doing in an integrated way, that we are going to separate actually. And for each function, we will have someone who will be having their part. So that is a very good thing. So that is what I understood, that that our network inside is going to be more democratic. So more people will participate, more entrepreneurs will come. So that is a good thing. And again, for student community, I will have. I want to add one word, that eCPRI sir is frequently has used. So that eCPRI means Enhanced Common Public Radio Interface.
Right.
So just for eCPRI, and frequently you means our these speakers are using the word low latency. So just I will again give a layman example so that you all students come to know that low latency. When you start your bike, you put your hand on accelerator. The time is take to speed up actually. You put your hand on the accelerator and it takes some time to speed up. So that time difference is called low latency. When we talk of latency, means that time has to be very small. As you put on hand on your accelerator, the speed should go high. So that is actually latency. So thank you, sir. And again, now I would invite third speaker. Sir, question answer session we will take in last. So please, sir, stay with us. We are getting the questions and we are making a note of that also. So now I invite the third and last speaker, Ms. Neha Satak, madam. She will be delivering E-band wireless backhaul and integrated access and backhaul. She is from Estrom Solutions. So over to you, madam. Please proceed, ma'am.
Thank you so much, Mr. Subhash. Let me just share my screen. I hope you're able to see my screen now.
Yes, madam.
Yes. Great. Thank you so much. I am Neha Satak. I am the co-founder and CEO of an Indian company working in the space of backhaul products. We primarily work on E-band radio to deliver gigabit speeds, to towers, not just in urban areas but also rural areas. So first of all, I would like to thank NT-PRIT for this opportunity to present at this forum. And second of all, I would also like to compliment all the speakers, the two speakers before me, who have actually very adequately covered the requirements for transport, backhaul, mid-haul and front haul in a 5G network. Thanks to them for laying a very good ground on which I can present in terms of my content. So the content of my presentation will be, I will first talk about the current backhaul infrastructure and the requirements in the country. I will also talk about the available technologies, available for backhaul. I will highlight the integrated access and backhaul, IAP, which is basically the new trend which is coming up. I will also talk about, a little bit about the satellite backhaul, because I think that is also, the upcoming thing that we should all be aware of. And then I'll briefly mention about Astrom's product roadmap, and if time permits, we'll talk about rural broadband. So with this, let me first talk about the different backhaul requirements that we have in the country, and I think these requirements mainly vary in terms of the data throughput and the distance of the backhaul link that one needs to cater to. So for example, in most urban areas, about half a kilometer to 2 kilometer is kind of the distance typically that one looks for when talking about even front haul, mid haul and backhaul in the 5G network. The data throughput, current 4G requirement is probably upwards of half a Gbps, but as the previous speakers also mentioned, that when it comes to 5G, the front haul and mid haul will have much higher data throughput requirement, going up to even 15 to 20 Gbps. In rural areas, as we all know, we are a country with a lot of population living in the rural areas. So it is also important for us to make sure that 4G as well as 5G services are delivered in rural areas along with broadband. So for rural areas, the backhaul requirements are that it should cover a distance of about 3 kilometers to 10 kilometers. And a data throughput of at least half a Gbps to 2 Gbps, expandable to even more, as the data consumption increases. In suburban areas, one of the things that we have seen in very big cities, big cities, is that a lot of times there are a lot of development going on around the city, new areas coming up, and we sort of need to empower telecom operators as well as broadband providers to sort of serve these areas, with high capacity, high capacity throughput broadband as well as telecom services. So suburban areas, typically are, typically require, backhaul connectivity to be extended between 1 kilometer to 7 kilometers. That has been our, assessment, and a capacity of, let's say, about half a Gbps to 5 Gbps kind of data throughput. So these are just numbers that we think, what we have seen. Of course, these can, depending on the state as well as the location that we are talking about, these numbers do change a little bit. But overall, this is the kind of requirements that we have seen. Now, just talking about the current state of the backhaul infrastructure in the country, right? We are a country which uses a lot of wireless backhaul. In fact, 70% of the cellular sites are today connected with wireless backhaul. And we have fiber, we have a lot of fiber, but we don't have fiber going to each and every area of the country. And with the upcoming 5G deployment, this requirement for connecting cell sites, is going to only multiply, as also the previous speakers have mentioned that, the cell size itself will become really, really small, and there will be a lot more cell sites to connect. And the current microwave radios, at least what is deployed in the country, is of course was geared towards the previous generations of telecom networks, and they are they were probably suitable for that, and now the thrust is to upgrade those with newer wireless backhaul technologies, which can cater to at least gigabit data throughput, and of course low latency, which is something that everybody has really highlighted in this forum. So in terms of the technology choices, we see a lot of innovation happening for different parts of these three genres that I talked about: rural, suburban, and urban. The main things that come to the forefront are basically sub 6 gigahertz fixed wireless radios, which are being utilized for rural broadband delivery at many places. V-band technologies, which is basically 60 gigahertz radios, which provide short range but high throughput capacity, and then E-band radios, which also previously my previous speaker also mentioned. That E-band is basically very, very critical for actually deploying 5G networks, especially because they can deliver very, very high throughput, going up till 10 Gbps to 20 Gbps. And then we have also experiments happening in the FSO space. Some of the products that are getting tested in FSO space, which is frequency of light, and what are called the high bands. The MM-wave fixed wireless products, which mainly operate from 28 gigahertz to 40 gigahertz. Which are being used to mainly solve the suburban data requirements in many countries. And then we have traditional microwave radio, which all of us are very well aware of. So what I'm going to do is I'm going to talk about each of these solutions and talk about the advantages and disadvantages, because as a company we believe that all of these network solutions, backhaul solutions, are required to really cater to the different requirements in the country. So in terms of the sub 6 gigahertz fixed wireless, one of the main thing is that, of course, most of the times the frequency in which these radios operate are unlicensed. So, they have that inherent advantage of having no spectrum cost. They can go for a very long range, and they can work for non-line of sight, links. So that those are really, really great advantages that sub 6 gigahertz fixed wireless bring to the table. They are low cost as compared to fiber. And the disadvantages are that, of course, low data capacity and, possibility of interference because these are unlicensed bands. So those are, some of the disadvantages of this product. The second, technology solution that we have available is the V band, which is 60 gigahertz. At these frequency bands, very often the oxygen absorption is high, and so the range is limited to about 400 meters. Even though the range is limited, but the data throughput that can be achieved at these frequencies is really high because of the high spectrum availability. This is expected to be unlicensed. It is unlicensed in most parts of the world, and probably also expected to be unlicensed in India. But this can cater to a lot of high capacity requirement for short ranges, in urban especially. The free space optics, of course, there is a lot of experimentation going on there. Infrared frequency ranges, high data capacity possible, again because of the high spectrum availability. No spectrum issues, but of course they have some problems when it comes to fog and rain fade, higher than what the microwave and E-band links have. And so there is a lot of technical issues that I'm sure people working in FSO are resolving. Some of them are stringent deployment requirements because the beam width is extremely narrow. So the alignment becomes very, very challenging, but I'm sure there are products which are sort of overcoming these challenges. The mmWave fixed wireless radios, which operate from 28 to 40 gigahertz, which are being used for 1 to 2 kilometer distance, majorly to really extend the range of fiber to suburban areas to deliver, broadband services. In some parts of the world, the only disadvantage of these using these frequencies is that they also overlap with the SATCOM frequencies and also 5G access bands. So, but I'm sure with the kind of spectrum planning, these issues can be overcome. And also these frequency bands are expected to be auctioned, so spectrum cost is also a consideration when using these radios. Then we come to E-band, which does require line of sight. So that is the probably one of the main consideration when deploying backhaul in E-band. The second consideration is that it also undergoes rain attenuation. But on the advantage side, it can actually deliver very high data throughput going till 20 Gbps. The capex of the deployment can be extremely low with the technology evolving every year. So in our experience, we majorly work on E-band, and we have seen that the capex can be quite low, as compared to other solutions, for backhaul, especially when you use E-band in a multiple point-to-point kind of setting, which is what we have, sort of innovated in our company. I will talk about that towards the end of the presentation. But also because of the possibility of forming very narrow beams, you can actually go very long distances up to 10 kilometers. So that is very advantageous when it comes to wanting to solve the rural backhaul problem. Versatile frequency to use for both broadband delivery as well as telecom services in urban as well as rural areas. So a little bit about what Astrom does. So Astrom as a company has been working on developing the world's first multi-beam E-band radio. So most of the E-band radios available in the market are only point to point. We are the only company who has multiple point to point radio available. And each of the link that we form are fully compliant with the narrow beam licensing model that has been adopted in most parts of the world. Again, it goes without saying that E-band has, a large spectrum availability of about 10 gigahertz, which makes it possible for, E-band radios to achieve 20 Gbps kind of data throughput. As a company, we have also really focused on, bringing out the power of software on the hardware, and so we have a lot of proprietary algorithm which makes it very easy and simple to deploy E-band radios. Given that these are narrow beam radios, with stringent alignment requirements, so we make it really easy because of the kind of technology that we have developed, and we have also a lot of algorithms developed to help operators reduce the OPEX cost. So for example, antenna misalignment, SNR management between links, all of this is actually done automatically and remotely. Of course, when it comes to 5G, I will talk a little bit more about that in my next few slides, how E-band can be a really good solution for backhaul in 5G networks. So let's take a step back and talk about what kind of data is getting generated on the access side, so that we have sort of a view of what will happen, what somebody needs to cater for in the backhaul. I gave you some numbers in the beginning of this presentation, but let me substantiate that with some more numbers. So if you look at maybe we talk about 4G and 5G primarily. In the 5G, in the 4G networks, the data rates that we see coming out of an access radio are about 720 Mbps max, and the latency requirement are 50 to 100 milliseconds kind of requirements, and the cell site is about 400 meters to 1 kilometer. Um, so the backhaul basically needs to cater to these kind of data speeds, but when it comes to 5G, the requirement actually increases quite drastically. Especially, the numbers here are only projected, for backhaul, but when it comes to front haul and mid haul, the data, requirement can go much higher. I will show that in my next slide, next few slides. But the main promise of 5G is to deliver very high data rates per user, 50 to 100 Mbps. And as everybody has mentioned before me, that you cannot achieve these kind of data rate delivery unless you have a solid backbone, solid backhaul, to support these 5G NR sites. And latency is another, critical thing that defines a 5G network, which needs to be really taken care of when it comes to a lot of the time sensitive applications related to industrial and automotive. And of course, with this new era of 5G, there is a lot of, it's no longer a homogeneous kind of a deployment where, the network is closed, everybody needs to talk to everybody else. And so it's a very, very diverse environment in which products need to actually work together from different companies. So that's kind of the three fundamental things that we look for when we talk about what kind of radios should be deployed for backhaul, front haul, and mid haul in a 5G network. So just to talk a little bit about an example of what kind of data throughputs we can expect in front haul, mid haul, and back haul. So this here I have taken just an example of a 64 massive MIMO RU, which is using a 100 megahertz channel bandwidth and has 3 sector per cell. You're looking at a front haul of about 4.8 Gbps, mid haul of 7.2 Gbps in this kind of a star, sort of hierarchical architecture. What is important to note is, first of all, fundamentally the throughput has to be in Gbps speeds. Second of all, it is also important to note that because of the number of cell sites that will be there, multiple point to point, or rather one radio actually talking to multiple cell sites is kind of something which is advantageous, mainly because it can help reduce the capex cost drastically. Because you're going to have many more cell sites which are going to be powered by a cell site which is powered by fiber. So it's kind of high data, as well as at the same time being able to power multiple towers, as compared to just to point. And that's kind of the reason why we, focused in our company to develop really the multiple point-to-point technology in E-band, because it can deliver data throughputs, as well as it can deliver sort of this spread, to reduce the capex cost. Then if we come to rural broadband, I think rural broadband has its own challenges. I think we have a lot of fiber deployed, but I think the fiber, it's very, very difficult, time consuming, as well as costly, and both in deployment as well as maintenance, to actually take that fiber to each village. So what we also need backhaul technologies to do is to fill this gap which is created between the fiber and the end consumer. And that gap in some states may even exist between a district level fiber which is laid to a gram panchayat, and in many states mostly the gap is between the gram panchayat to villages. So this is kind of a another key requirement which we think E-band can solve. So that's something that I will cover more in detail in the next few slides. But let me talk about one more topic which is also part of this of my presentation, which is integrated access and backhaul. This is a new trend which is coming up, where instead of relying on fiber, people want to have backhaul and access to work together. So basically the fundamental thing is that why not make the strategy for telecom operators to use wireless backhaul as an inherent solution for powering their cell sites, given the large number of 5G cell sites that will come when we deploy the 5G network. So what is proposed, in integrated access and backhaul is that, there are two options that are proposed. One is that can we use the same band that we are using for access also for backhaul? And so in some way, either it is time sharing of the spectrum which is allocated for access, or basically frequency division, kind of a scheme to sort of utilize the same spectrum which is allocated for access for also for backhaul. Of course, this can result into some advantages and some disadvantages, which I will talk about in my next slide. But the option 2 is actually to use basically integrate backhaul and access, which operates in two different bands, but really make that as one solution which can be deployed. So when you're deploying your access radio, you're also deploying your backhaul together with it, and so you really solve that problem of needing to connect every cell site with fiber. So you can have fiber laid at certain cell sites, and then sort of use wireless backhaul to connect to those cell sites. So that's kind of a very powerful solution which is being explored by many around the world. So a little bit talking about the in-band IAB, right? So of course it saves the capex cost a lot, because the same antenna can be used for backhaul as well as access, because they both are operating in the same band. It maximizes the use of expensive spectrum, reduces throughput available but the disadvantages are that it also reduces the throughput available for access, because you're really either time sharing or frequency sharing the spectrum which is available for access. So that's something that operators need to keep in mind. Also, the backhaul throughput may not be very high because of the limited channel bandwidth that is available. On the other side, the outband IAB is something that is also very interesting, because now you're sort of decoupling the backhaul as well as the access frequencies. You can allocate separate bands for access and separate bands for backhaul. A lot of time it is proposed that millimeter wave bands can be used for backhaul or access, and the sub 6 gigahertz can be used for backhaul or access. Of course, there are multiple combinations that can come out of this. This way it is basically easy and cost effective to deploy, as fiber is not needed at every cell site. But when it comes to capex, of course, it is more expensive as compared to in-band IAB, because possibly different antennas are required for backhaul as well as access. A couple of things that we wanted to sort of bring out as something that we think at Astrom is possible is why not leverage outband IAB also for rural areas. So we are looking at integrating a Wi-Fi 6 kind of access technology, and into something like an E-band, which can give you the capacity and the range. With that combination, is it possible to solve a lot of the rural challenges that we face today in the country? The second idea that I sort of wanted to bring out was that 5G NR radios obviously require a large throughput at the back end. So could we have E-band as the backhaul frequency, and 5G NR in sub 6, as well as the high bands can be used for 5G NR. So can we do sort of these integrations to strong integration to make sure that the deployment cost comes down and is more effective and faster to deploy 5G networks. So those are the two things that I sort of wanted to bring out from an Astrom perspective in this conversation. Last but not the least, I think it is also very important for us to be mindful of, the new developments that are happening in the satellite domain, with all the LEO constellations being launched. There will be one more possibility of, having backhaul capacity, towers actually powered with satellite networks in LEO, MEO, and GEO. And all of these three different orbits actually provide different kind of latencies and different kind of throughputs. So just to give you a little bit perspective on the evolution of satellite networks, we majorly have geostationary satellites that are providing communication requirements in the world today, and they have of course a high latency of 250 milliseconds because of the distance that the satellite is at from Earth. But what is interesting is the new LEO constellations that are coming up, and which can provide actually latencies, between 3 to 10 milliseconds, which can be a good option for backhaul where fiber or wireless backhaul cannot cater to the needs. Examples like in-flight connectivity, as well as maritime connectivity, and also remote areas. This can be particularly very effective, to use. Just wanted to bring it to your attention that satellite networks will not just deliver internet to the end consumer, but they can also power your cell sites. So that's why they can not just be in the tier 3 but also tier 2 and tier 1 in terms of the network, where they fall in the network. So just going, back to, what Astrom offers as a company. So we work on E-band radio frequencies, repeating this part again, but we are again the only company in the world who has developed a multi-beam E-band radio, so which is basically able to form multiple E-band links to multiple cell sites from a single radio. And it's a fundamentally different technology which has the antenna completely integrated into the radio and has the power of software over hardware. So we are able to do a lot of the link alignment as well as link management functionality all in software. So in terms of our product roadmap, we do plan to cater to the front haul, mid haul, back haul networks in the next version of our product, which is coming out soon. And thirdly, we also have a product portfolio which is getting created in the satellite communication domain. We believe that the merging of the terrestrial networks with the satellite network is very, very important, for essentially, leveraging one more type of technology to fulfill all of the different diverse requirements that we have in the network today and also in the upcoming future. So what we bring to the table is, low cost. We reduce the capex cost by bringing this fundamentally different technology, and more so reduction in opex cost, which is very important, in terms of the maintenance of the radio as well as the initial installation. Quick deployment, because it can be a very good, last mile connectivity solution for rural as well as urban and suburban, and of course easy maintenance because of all the software features that we bring to the table. So I think with this I would like to stop here, and just check on time, and if I think I'll like to give it back to the host.
Thank you, madam. Thank you for your nice talk, and the topic that you covered, that integrated access to backhaul, and the concept of share, we could understand in a better way actually how that access network and backhaul is going to share the spectrum also, and the free space optics that I think in my engineering days I used to read there, say that someday that free space optics will be used for communication. So that at least you saw that you were able to say that something it may be reality also, and the way how satellite is being going to change it. Satellite is always changing the society. So now again that it is again a new epoch for satellite that through this Leo constellation, a new era of telecom is being it has come. In fact, rather we can say it has come. Now I think someday we will able to see that those things also, that when that 5G things come in our hand only. So then, so thank you very much, madam, for all this night talk. And now we will proceed to our next session for question answer session. So the questions already we have received questions in the chat. So okay. So some questions we already got in the chat, and Sri Vivek ji has already answered. But I would request, sir, the question was from Sunil Kumar, sir, DDG Wireless Access here in NTIP. Sir, if your query is answered, if you want to ask, then please ask your question also, sir. Already Vivek sir has written. If any other further query, please you may ask, sir. Please, sir. Sunil Kumar, sir.
Yeah, that is fine, Subhash. I think he has answered. So.
Sir, your query already Vivek sir has written, but if you want to have something more, you please ask, sir. Vivek Dixit, sir.
Yeah, Vivek, just I was curious about this 15 gigahertz and 18 gigahertz deployed. So are you there, Vivek?
Yeah. Can you hear me?
Yeah, so there was a large deployment you can see of the conventional systems on 2G, 3G and 4G working on 15 gigahertz and 18 gigahertz backhaul systems. And this spectrum is sitting in between our wave and the sub-6 band. So it can be a precious spectrum. So, and which is locked up in this KU band, which is being used for backhauling now. So with this evolution of IAB, I was just wondering that whether any efforts or any thoughts are there in using this spectrum also into access. But Astrom also has told in Madam's presentation that this IAB can be having two flavors. One is segregating the spectrum into the access and the backhaul separately and managing within the band in a different way. So has anything got evolved from your Ericsson's experience globally that anything is moving in this direction?
No, I think, as Madam also mentioned, there are two ways to do it, either in band or out band. So I think, various researches are going on. And as I mentioned, that it will also involve the various policy making from each, country specific things. So it is still under investigation. And as an Ericsson, there is no specific, recommendation wise. We are still evaluating both the options. Yeah.
Okay. And coming to network slicing, is it commercially implemented by Ericsson anywhere?
Yes, network slicing, especially if we talk about EMBB slice and FWA are some of the use cases which we have, seen coming up, and that has been implemented. However, like URLLC and some of the more complex use cases are still evolving and still under discussion. So probably by next year, we should be seeing more slices coming into the picture with more use cases. And even if we talk about like URLLC, it is a generic name for all the applications which require ultra reliability and low latency. That may talk about robotic arm operations, or that may talk about driverless cars or many other things. So very specific use cases are still yet to be evolved. We are discussing with the customers that what kind of applications are they really looking for. But yes, to start with, network slicing has been already started with majorly EMBB and FWA fixed wireless access as two slices clearly defined with different SLAs there.
Okay. And you also mentioned, as well as Rahul also mentioned, about time sensitive networking features going forward in 5G. So does it require any feature sets in the transport layer, or it is being handled at the application level only? This TSN kind of.
So, Sunil sir, it needs special features at the transport box. So, CIPRI and eCIPRI have very stringent requirements which connects the RU unit with the BBU. So to address that, the TSN box has those specific features, which is actually replacing because initially, this front haul requirement was addressed by a pure optical box. So we used to have a dark fiber connecting, the RU unit with the DU unit, but it is not cost effective. So this TSN is a replacement for that dark fiber optical solution where it can address those requirements of CIPRI and eCIPRI. So it is an inbuilt part of the transport box.
So thank you, all the speakers. It was a very useful session. Thank you very much.
Thank you, Ravi sir. Sunil sir.
Thank you, sir. Sir, another question we have received on the chat that it is from Rahul Puri sir, asked by Sri Brijesh ji, and or the OEMs are planning to deploy 5G technology for captive network also.
Yes. So in Nokia, we have specific solutions. So we have 3 different flavors of captive network. We have a product known as NDAC, which is for a very small network, and we have deployed that along with BSNL in our Chennai factory in India. So that is for very small network. Then we have a different flavor known as CMU product, and that is for mid-size network. And then we have a cloud core solution, which is for big network. So we have captive network for airports, for mining, for specific use cases for like utility connecting applications like electric meters, water meters, gas meters, in the USA. So yes, the answer is we have 3 different flavors, NDAC, CMU, and Cloud Core, to address different requirements. And these solutions support not only 4G, but 4G and 5G both.
Thank you, sir. Sir, another question is, what measures are being taken or will be taken for sustainable greener 5G and beyond? Please comment on the feasibility of using renewable energy resources for communication equipment, for example, RSU. The question is asked from B. Sainath for Rahul sir.
Okay, very interesting question. I think a very relevant and important thing, going forward, zero footprint is something what is the aim of all the enterprises and all the countries. So when we do cloud RAN architecture, in these kind of scenarios, we are clubbing the resources of radio or the BBU at a common location, which actually reduce the footprint from the radio power requirements. At the same time, our new equipments are not very power hungry. So the per watt power requirement for the radio equipments have reduced drastically. I don't have the exact numbers, but yes, as Nokia, we are very serious about these things, and we are working on reducing the power requirements for the various equipments we have.
One interesting question to Mr. Puri from Akam Mukherjee. How do you see the uses of various PON technology in 5G transport, especially keeping in view the latency in mind?
Sorry, can you repeat? I lost your voice in between.
How do you see the uses of various PON technologies in 5G transport, especially keeping the latency in mind?
Yeah, so currently for front haul, if you remember one of my slide, I have positioned the various transport technologies. So currently for front haul, ONT, OLT is not suitable. But then they are more for connecting between the DU and CU unit and CU2, the core location where the bandwidth requirements are very limited. So currently we don't position OLT, ONT for front haul.
Thank you.
Any participant, if you have any question, you please ask your questions also. Other participants who have not written, if you want to ask, please raise your hand. We will unmute you and so that you can ask your question.
In the meantime, I have a question from Mr. Rahul Puriji.
Sir, bataiye.
You talked about SFPs, no, directly being connected to the macro site.
Right.
So does it do away the requirement of CPRI in that case? How does it work? Because when you connect an SFP, how is it converted back into RF?
So, for that architecture, it will work on the distributed architecture. It will not work on the centralized RAN architecture, because OLT ONT doesn't have that stringent latency scenario. So if you have a site which works on the traditional classic RAN architecture, this can be used. Now, one of our colleague, one of our friend asked about the power requirement. So if you do these kind of solutions, it actually reduce a lot of power requirement. So in one site, you don't need to put a specific transport equipment, especially because it uses a lot of power and space and cooling. So these kind of solutions are eco-friendly also. Because let me tell you, all the sites will not be cloud RAN. There will be a combination of cloud RAN and classic RAN architecture. So those sites where you have an existing ONT OLT architecture, you can use this, because as I said, this cloud RAN requirement is only required if you have very stringent use cases for in a specific area or specific domain. But if you have existing OLT ONT network underlying, and if you want to reuse that and you don't have any very stringent requirement in terms of SLA KPIs, this classic RAN can be used with this SFP ONT solution.
Thank you very much. Nehaji is there?
Yes, sir.
How are you, madam?
Good, sir. How are you?
Excellent presentation. I just wanted to know this boxes that you have shown about E-band radios. Is the antenna also included? It's on the face of the equipment, or it is a separate element?
Yes, sir. So it's inside the box. Actually, the antenna is completely integrated. It's a phased array antenna. So it's just a one box solution.
So this is the multi channel system. It becomes a point to multipoint kind of system, is it?
Yes, but one differentiation from point to multipoint, it forms these multiple narrow beams instead of forming a wide beam. Yes, sir.
Yeah, sure. So it becomes point to multipoint kind of system.
Yes, yes, sir.
And then where are you going on in terms of modulation? Is it up to 512 QAM?
Currently, sir, we do 256 QAM. We are going to add the 512 QAM soon.
Okay. So on a channel of 1 gigahertz, how much is the throughput you're likely to get?
Yes. So, sir, current radio, the current radio which we have ready to sell is actually using a 250 megahertz channel bandwidth. So we are able to do a 2 Gbps throughput. And the next radio which we are coming out with this year will actually support 1 gigahertz and possibly support 5 to 8 Gbps kind of data throughput.
That will be nice. And one more question, you had passingly told about Wi-Fi 6 technology being transposed to this E-band. So will there not be a challenge of physical layer being transported, transposed there? That will be a great challenge, isn't it?
Yes, sir. So what I mentioned was that can we integrate basically Wi-Fi 6 technology, which inherently brings the mesh as well as the unlicensed spectrum. to deliver data throughput in like a 400-meter kind of area, and then use E-band as the backhaul. So the physical layer for both are separate. The RF is separate, but there is like a merging of that in the baseband. So can we do that to sort of create an effective solution for rural broadband?
That will be interesting. Thank you very much.
Thank you, sir.
Subash, any other question?
Anyone, if you want, anyone want to ask question, please raise your hand so that otherwise we may proceed towards. Okay, thank you. So,
I think we can close now.
So, shall we proceed to vote of thanks, sir? Please, with your permission.
There is a question from Mr. Ashok Jha.
Yes.
He has raised hand, so you can give him floor.
So,
thank you, sir. Good morning, sir. Just one small question from Neha ma'am. What is the range of their E-band? Like V-band has a very small range within a kilometer. What is the range of E-band? That's what I wanted to know.
Yes, sir. So expected range is about 10 kilometers from our radio.
Just one supplementary to that. 10 kilometers E-band and V-band is just 400 meters or maybe within the kilo. What is the key difference that brings out this big change in the range?
Yes, sir. So there is a physics issue. So in V band, the oxygen absorption is very high, especially at certain frequencies in the V band. So because of that, the attenuation in V band is much more than E band. So that is the main reason because of which the ranges of these two products are very different.
Thank you, sir. Thank you, ma'am. Thank you so much.
Yes.
okay, thank you. So let us now we have come to the last part of the session. So let me read out the vote of thanks. So I first thank our DG NTI PIT Sri UK Srivastav sir for guiding us to organize such a wonderful seminar. And sir, today is a birthday of Swami Vivekananda, and entire nation is celebrating National Youth Day. And I think this could not be nothing could be better than this, that we all the telecom people are sitting here and discussing the core telecom issues. So I think under your guidance, sir, we have celebrated National Youth Day in a true sense. So thank you, sir. Thank you very much, sir. And I also thank our DDG Sri Raju Sinha sir for guiding us, guiding the transmission and NGS division team to finalize the speaker, and in fact topics finalized. When we were finalizing topics, so many changes came, but finally we have come with a very logical sequence of speakers and everything. I also thank all the speakers, Sri Vivek Dikshit sir, Rahul Puri sir, and Neha madam, and the beautiful way you actually you proceeded in your discussions, and it was very interesting. Actually, just now when this webinar was going on, Didi sir just told that all the persons who came, and I am seeing that no one has gone back. So that is the quality of the speakers, that everyone who came and joined the webinar, and he or she has been connected till the last part of the session. And this webinar was on actually the topic of backhaul, but there is a front haul, mid haul, and like that Rahul Puri sir gave the name that any haul. So in future also, after not only this backhaul, we may organize webinar for front hall and mid hall also, and all the speakers you are. We may again invite you, and in the last, I would like to thank all the participants who came, who joined, and participated in the discussion and understood the concept. And I also want to thank my colleague Mr. Jaipalji and all the NTI team who are working in this background to make the webinar successful. So thank you everyone. Thank you for making this event very successful. And if you have any other queries, you can write to me. My email ID, phone number is also there. My DG sir, Raju Sinha sir, email ID and mobile number are also there. So if you have any query, yes, sir. If you have any query, you please can write. And if you in your mind you have any topic that you want to you want NTI to come forward to have a discussion on that, you can tell your topics also, not only questions, but rather your topics also. We keep on organizing such seminar. We as a NTI as a training institute, it is our mandate to organize such seminar. It is mandate given to us that to organize such seminar and disseminate the knowledge. So if you have any other topic you want to hear from us, just let me know. Just send an email. We will do it as early as possible. And thank you everyone. So now now this webinar is ended. So now thank you for everyone. So now we are leaving the means we are ending the meeting. So everyone can leave. Okay. Thank you everyone.